this lesson we are going to cover the let and the const keywords that we have been mentioning so far, but we didn't say what are those keywords useful for. So let's do that right now before going any further. So plain JavaScript just has a var keyword that allows you to define a variable. And what could go wrong with declaring a variable, right? That's one of the base functionalities of any language. Well, the var keyword in ECMAScript 5, so plain JavaScript, it has a problem compared to equivalent features of other languages. Let's have a look at it. Let's write a slightly more complex program where we are going to test for the value of message. So we are entering here a block. So in this block here, we want to define another variable, which let's say we are going to call it e. And we're going to define it as a number using a type annotation. Now I will just paste in here some very simple code that it's just a for loop. It's going to loop through the e variable and it's going to print it 3 times to the console. So let's try this out. Notice that you don't need to run again the TypeScript compiler from the command line. Your IDE is actually continuously compiling the program. So any changes that you made to the program, you simply hit Ctrl S to make sure that it's saved, and that will trigger a new hello-world file with your latest changes. So you can simply refresh the browser and you can see here that we have printed to the console the value of the e variable 012, which is what we would expect. But now take a look, this variable here, e number that we have defined inside this scope, this block, this is actually still visible outside the block scope, which is rather surprising for developers coming from other languages other than JavaScript. Let's print it out to see what's going on. If we simply print e to the screen after this loop, we would expect maybe that this would be undefined because this is a block scoped variable, but take a look. The value of e is still present there, okay? So this means that e, the e variable, is visible outside the scope of this block. This is because in plain JavaScript, using the var keyword is not block scoped. So if you define several blocks, several if blocks that are nested inside each other, and you would like to have a local variable that is only visible inside the block scope, that is not possible with the var keyword. And that is exactly the problem that the let keyword solves. So if now instead of declaring e as a var, we declare it using the let keyword, take a look at what happens. So this is still a variable, but you now get an error here, cannot find name e. So e is now a block scoped variable, so it's not visible outside this block, the if block. It's not visible in this statement here, the console.log. So block scoped variables are possible using the let keyword. This might lead to the question, should we still use the var keyword while doing TypeScript programs? I don't think so. I think that if you have a variable, you should always make it a block scoped variable and use the let keyword. Var is just there for backwards compatibility with plain JavaScript. Does this mean that we should declare all our variables using let? Well, actually, I'm going to suggest to you to prefer another keyword by default instead of let. So one of the best practices of developing programs that are easier to read and to maintain is to avoid mutable states. So if we declare here this variable as a const, we have effectively declared it as a constant. So this means that this variable is only populated at initialization time, and then later in the program, if we try to reassign it to another string, so the empty string would be a valid value for a string, but we have here left hand side of assignment cannot be a constant. So const is really a simple way of declaring a block scoped immutable variable. So let's summarize the 3 keywords var, let and const. So var does not have block scope. It should not be used while building new TypeScript programs. You should either choose let or const instead. And which one of the two to choose? We should use const if we want to declare the variable as being immutable, and this is generally a good idea to set a variable its value and initialize it only once, and try to build our program without relying on variable mutation. This is generally a good approach that leads us to less bugs. But if we need mutable variables, block scoped mutable variables, we can do that using the let keyword. One important thing to bear in mind about const is that when we apply it to a variable that it's an object, only the object reference is immutable. Try to assign message to null, we get back an error saying that we cannot do a second assignment to a constant after it has been initialized. But let's say that, for example, we want to change the property hello. Let's try that. As you can see, the program compiles, so declaring message as const does not mean that the whole object is immutable. It's only the reference to the object which is immutable. So to further illustrate this, let's say that we declare here a second reference to the same object and we make it not a constant but a variable. So we use let and we are going to point it to message. Now this second reference to the same object can be mutated because it's declared with let. So if we say message2 equals null, as you can see, the program compiles successfully. So it's important to understand that const is not about deep immutability of an object. It's really about creating an immutable reference, an immutable variable. So I hope that this explains the difference between the three keywords and when to use each. If you would like some of the code of this lesson, you have here the git tag section -1-2 where you can go directly to this version of the Hello World program. So now let's continue exploring more features of TypeScript, more features of the ECMAScript 6 standard that we can already use today. Let's now introduce another ECMAScript 6 feature, arrow functions. So as always, we're going to introduce the feature when we're going to explain what is the problem that the feature is trying to solve. Let's start with this simple program where we define a constant message. We have also defined here, using the function keyword, we have defined a function called sayHello, which takes as parameter a message and logs it out to the console. And here we are calling the function, passing it in the value hello world. If you go to the browser and we refresh it, we can see here that hello world is being printed to the console. Now, this syntax here has an alternative syntax. A function in JavaScript is assignable to a variable, so functions are values. They are valid values for a variable. So we're going to define here an immutable variable. We are going to call it sayHello, and we are going to assign it to this function body. So as you can see, this syntax doesn't work simply with the parameter and then the block scope. But if you add in here at this point the fat arrow, that's also how it's called, we have defined here a function that takes as input one parameter and logs it out to the console. So let's try this out to see that this is still working and this is still valid ECMAScript 6. So the arrow function is basically an alternative way of defining functions compared to the plain function keyword. But what's the advantage here? For example, if you only have one argument, you can actually remove the parentheses here. So if you try this out again, you can see that it's still working. Also, this function here only has one line. And that's a rather common case. Many functions are very small and only have one line. So in this case, with the arrow function, you can define it by removing the curly braces from around the unique statement of the function. If we try this out again, we can see that everything is still working. So this is one of the reasons why the fat arrow or the arrow syntax might be useful. It's a way of defining functions in a more abbreviated way. Now let's see another thing why this syntax is useful. It has to do with the use of the keyword this. In order to understand what is the problem that the fat arrow syntax solves relating to the this keyword, we have switched here to another small example where we are defining a function person, but take a look at the capital P. This is actually the definition of a constructor function. we're going to create here a new instance of person, and we're going to pass it in the name of Bob. We're going to assign it to a constant person, and we're going to call the method say hi. So what is the problem here? We are taking the name of the person and we are assigning it to this. So we are assigning it to the instance of person. But here we are defining a method. So this is like we are defining a class. But here also as a member variable of the instance person, we are defining here a method. We are defining a function that we can call named say hi, which simply calls set timeout, and we are going to wait here for 1 second. After 1 second, we are going to log out to the screen, hello, my name is, and we want to pass in the name that we have passed in the argument of the person function. Now, take a look at this warning, potentially invalid usage of this. Let's run this program and try to see what is going on here. What we get is, hello, my name is, and then there's blank. There is nothing printed to the console. We don't get any error as well. So this is actually something. It's not undefined because this .name does not throw an error. So what's going on here? What happens is that in this case, this is pointing to the global scope of our runtime. In the case of the browser, this means that this is pointing to the window object. So what is going on here? What is the problem, and how does the fat arrow syntax help to solve this problem? Well, the problem is that each time that we create a function using the function keyword, we are essentially creating a new scope, as we have seen before. And inside the scope, this points to the scope, so we can use the scope to store information, to store variables. We are using here this.name to store the name of the person in the person instance. And here we are trying to retrieve it from the place where we have stored it. But here inside set timeout, we have created a new scope. Unintentionally, we have created a new scope. So here we are trying to retrieve this.name from this scope here of this function, and that is a different scope than the scope of this function here. So this is a behavior of the this keyword that is really not ideal when we're trying to do this type of programming. What we would like to do here is define an anonymous inline method here in the middle of the body of the function, but we would like to have the ability to create a new function without necessarily creating a new separate scope. We would like the this keyword to refer still to this person function so that we can retrieve this.name. How would we solve this in a plain JavaScript? Usually what we would do is something like var that equals this. So we create a closure around this variable. We take that and we use it here. So now we can see this variable here. We have a new different value of this, but we can still see the variable that here. So that.name would point to this and we would retrieve the name. Let's see this in action. So as you can see, this would solve the problem. Hello, my name is Bob. But this is a little bit cumbersome and we would like to have a better way of solving this other than doing that equals this. And keep in mind this solution because we are going to see it in a moment. Now let's go back to the trouble situation. This has a different scope, so we get here undefined. One way of solving this is instead of using the function keyword to declare this function, we actually use the fat arrow function. Let's try this out. If we refresh the page, we get hello, my name is Bob. So whenever you define a function using the fat arrow, we are not creating a new scope for that function. We are reusing the scope on which the function itself is defined. In this case, the scope of person. Now, this explains another use of the fat arrow syntax. But you might be wondering at this point, how did TypeScript implement this? Well, if you look into the hello-world.js file, you will see that actually TypeScript did something very similar to what we did before, which is it created here a variable called _this that we had actually called that, if you remember, and it has used it here. So sometimes adding a new feature to the language, it's really as simple as this. So let's summarize. There are two reasons why the fat arrow syntax is useful for defining functions. It's an abbreviated way of defining functions without typing the function keyword everywhere. It's very convenient to define one-liners, for example. Also, in what relates to the this keyword, this avoids creating a new scope for the this keyword. So if you want to reuse your existing this scope, the fat arrow syntax is a great solution for that. One question that you might still have at this point is, should we still use the function keyword to define inline functions? I will suggest you to, whenever you are using inline functions, to always use the arrow operator syntax instead of the function keyword. It's more convenient, it's more concise, and you avoid problems that relate to the this keyword. The function keyword is great for example, defining functions that are named. So here is a suggestion of how to use this new functionality. After learning all about the cool features of ECMAScript 6 that TypeScript allows us to use today, we're going to now learn in this section and in detail the biggest feature of TypeScript, its type system. That actually gives it its name, TypeScript. We're going to learn the type system in detail, how to use it to build type-safe programs, and what are the advantages of building programs that way. Let's do some quick initial setup to prepare our environment to explore the TypeScript 2 type system. For this, we are going to create here a file, learningtypes.ts, and we are going to create here an npm script types examples. So whenever we want to run the content of this file here, learningtypes.ts, so this is currently empty for the moment. So if we add here simply a console.log section 2, let's now run this program, and we are going to use this npm script here. So we are going to do npm run types examples, and this is going to call the node executable to execute the learning/types.js file, which is here at the same directory as the ts file. This is being compiled automatically by your IDE. So if we run the program, we should have here in the console section 2. So our sample file is working. Let's now start learning the TypeScript type system. Let's now cover objects and types. Let's take this very simple plain JavaScript object that has two properties, so first name and last name. You might think that the type of this object is object. I mean, it should be a type that takes any property. This is what we would be led to believe, but take a look. If we try to add here another property address, we are going to get an error. It says property address does not exist on type, and we have here what looks like a type definition, which is an object that can only have two properties, either first name or last name. We're going to see in a moment how to configure the TypeScript compiler to allow such situations if we want to. But right now, let's focus here on this person variable. It's clear at this point that the TypeScript compiler is already defining a type and associating it to the person variable. If we hit Ctrl-Shift-P, we can see that the type is defined here, so it's first name and last name. So the type defined is an object that can only take these two properties. We could have defined this type explicitly by adding a type definition and defining the type here in line. So we will define the first name that needs to be a string, and we are going to define the last name, also a string. So as you can see, the program compiles perfectly, and it's equivalent to the version where the type is inferred. Now, we might want this to be just a plain old JavaScript object that could take any property. If we want to do so, we can remove this type definition and we can annotate here explicitly the type any. This means that this is an object that can have any property. And as you can see, we no longer get here a compilation error. We can do person.address or person.any other property. And also take the type definition of what we had before and define a type. Let's create a type called hasName, and we are going to assign it here this type definition. So hasName is an object with these two properties, which are strings, and only with these two properties. We can now use the name to define that person is of type hasName, and now we get back again the error property address does not exist on type. So as you can see, in TypeScript we can define our own types, and those types don't have to be the definition, for example, of a class or a primitive type. We can define complex types and compose them together. It's also possible to say that, for example, the last name property is mandatory, but maybe the first name property is optional. So let's say that, for example, we only had the last name. Right now, this will give us a compilation error saying that the property first name is missing. But if we define it as optional using this syntax, now the compilation error disappears. At this moment, you might notice that hasName, this kind of looks like an object-oriented interface. And actually, if we use here the keyword interface and we remove the equal sign, this is actually an alternative definition of the type hasName. We're going to learn when to use an interface and when to use the type definition in a later lesson. Right now, we are going to show that there is another important feature in action here at this stage, which is autocompletion. So if you do %, you will see here the multiple properties available via autocompletion. And this is something that is not available while using plain JavaScript. Now, one last example of type definitions. We can compose types together. So for example, if we define a new type hasAddress, which let's add here a property, street name, which is a string. We can now define a new type and let's call it person. And this is the combination of a name property, which is of type hasName, and notice the autocompletion again in action, and the address property, which is of type hasAddress. So we can define here person as being of type person. And as you can see, this is no longer working. We can add here a property name and we pass in the last name inside it. We still get an error. This means that the address property is missing, so we can mark it as optional. And now we no longer have compilation errors. So as you can see, these type definitions can be combined together to produce complex types. In TypeScript and in JavaScript in general, functions are also valid values that can be assigned to variables. So let's say, for example, that we create here a variable named hello. We can assign this, of course, to a string hello, but we could also assign it to the create hello message function definition. So a function definition in TypeScript is a valid value for a variable, and in JavaScript as well in general. A function is in itself a value that can be passed around in the program. Now take a look at this parameter. We are not defining it as a string here, so this could be anything. Here we are passing in a string, Bill, and if you run the program we get hello, my name is Bill. But we could have passed in here also, let's say for example, an object with first name Bill. If we now run the program, we can see that we get object printed to the console. So this is the default toString of object. So as we can see, this program is actually not type safe in the sense that we can pass in anything in create hello message, and we would probably want to restrict the type of name to be a string and not an object. So to improve this program and make sure that this accidental call of the create hello message does not happen, what we can do is we can add here a type annotation to the function parameter name. And now we can see that we get here an error. Argument of type first name string is not a string. Also take a look, this function here, create hello message, is returning a string, but we are not defining a return type for this function. So let's say that, for example, we define here a variable named message and we are going to pass it in the output of calling the function. So we pass it in create hello message and we call it with an argument of Bill. And now let's log out the message. So this is still a valid program. And if you click over message and you hit Ctrl+Shift+P, you're going to see that the type of this variable is inferred based on the type of the return inside this function. So TypeScript still knows that this message is a string, but we can also explicitly add it here. We can add a type annotation that defines what is the return type of this function, and in this case the return type is string. Now we might have many such functions in our program that create different kinds of messages. So functions that take a single input argument as a string and the parameter is mandatory and it returns a string. So we can define here a type definition and let's call it message creator. This type definition is going to be a function that has as first and only parameter of name and type string and whose return value is a string. So this defines a function type. Message creator is a function type. With this function type, we can, for example, define here a constant named creator, which is of type message creator. So this means that creator is a variable that can only be assigned a function with this definition here. So create hello message is an example of such a function. So if we assign it to creator, the compilation error is fixed. Let's use creator to call it with the parameter Bill and let's run the program. So as you can see, everything is still working as expected. Now say that we have added here a second parameter, so let's just call it extra and this is a number type. If we add here a second parameter to the create hello message, now we get here an error because this assignment is no longer valid. We are trying to assign a function that has two arguments as input and returns a string, but message creator can only take one argument as input called name. This would be solved if, for example, we declare this extra as optional. We can also define a function type as being an interface which only has one method. So let's say that, for example, we define the message creator like this. So interface, message creator, and in here we have a type definition that is very similar to the definition of a function. So we have here an argument which is name of type string and a return type of type string. If we now try this out, we can see that everything is still working as expected. So this is an alternative way of defining a function type. Let's cover some TypeScript 2 specific functionality, nullable types. So here we have defined an enum called player position and we have defined an interface player with a name and a position properties. Now we have here an object which is called Kobe, which is of type player. So let's add the type annotation here. Now this variable Kobe is of type player, but we could also assign it, for example, null, and we could also assign it undefined. And this would still compile, this would still be a valid TypeScript program. But we might not want this functionality. We might want to ensure that this variable is an instance of player and that by some reason it cannot be null or undefined. We would like the type system to help us define that, declare this rule. In order to do so, let's configure the TypeScript compiler to turn on the strict null check mode to prevent this situation from occurring. For that, let's head over to the command line to the root of our project. So take a look, we are in the root of our complete TypeScript course folder repository. Now we are going to do tsc --init, and this created here in this folder, it created a tsconfig.json. This file is a configuration file that configures the TypeScript compiler with some commonly used options. Actually, until this moment in the course, we were actually using the TypeScript compiler via the WebStorm IDE, and these options were actually already active. So, as we've seen before, whenever we use import and export that ECMAScript 6 syntax for modules in our program, we were compiling our program to CommonJS. We saw that before. We were compiling imports to the require statement and exports to populating the exports property. As we can see here, we were already using our target as ES5, meaning that we are compiling to a version of JavaScript that is currently available in all browsers. We could compile TypeScript down to ES6, for example, if our target platform would be ES6 enabled, but usually we compile to ES5 in most cases. Now take a look at these other two options. No implicit any set to false. We are going to cover what no implicit any is in a moment. Source maps, we will also have a specific section for debugging, so these two options will be explained later. Right now, we want to add here an option that is available since TypeScript 2 that will prevent this situation from occurring, so the ability to assign undefined to a variable that should be of type player. So in order to do, the property that we are looking for is strict null checks, which is by default false. We want to set it to true. Also, at this moment, we want to configure WebStorm to use this tsconfig. So use tsconfig. So this is why it's important that you put the tsconfig.json file in the root of the project so that WebStorm can take it from there. If you put it in another folder, WebStorm will not be able to use it, and you will have differences between the errors that WebStorm is displaying you from when compared to the results that you would get from the command line. So this way you will get the same results in both environments. If we go back to the program, we can see that now we get an error for this situation. So it would take a moment for the compiler to be adjusted to the new options, but we can see here that now we get type undefined is not assignable to type player. You can also see the same error here in the TypeScript pane in the WebStorm IDE. You have a list of errors of the current program. So we have effectively prevented this situation from happening. We cannot also assign it to null. If we try to assign the variable Kobe to null, we get type null is not assignable to type player. So this is exactly what we expected. As you can see, this functionality is really very useful to catch all those null-related errors that tend to pollute many of our programs, also errors related to undefined. So you might think, why isn't this option turned on by default? Well, this is so with TypeScript 2 due to backwards compatibility. So we want to make sure that programs that are written with TypeScript 1, we want to make it easier to migrate them to TypeScript 2. If we would have strict null checks set to true by default in TypeScript 2, that would introduce a major breaking change that it would make quite hard to migrate many programs from TypeScript 1 to TypeScript 2. So currently it's set to false by default to make it easier to upgrade to TypeScript 2. But if we are writing a new program, it's a great idea to turn this flag on since the beginning, because this is one of the main features of TypeScript 2. Now let's go back to this program. There are situations where a variable can be nullable, so it could be an optional variable. Sometimes it's null and sometimes it contains a player, an instance of player. So how can we tell that to the type system so that this program compiles correctly? We can use a union type for it. We can say that the Kobe variable is a player or null. And now the program compiles correctly without any errors. Notice that if we assign this to undefined, we still get an error. Type undefined is not assignable to player or null. So we could take this one step further and we could add here the type undefined. And with this, the program would compile correctly. So now with TypeScript 2, we get the possibility to say which variables are nullable, which variables can be undefined, and which variables are expected to always contain a value. So in the program that we are about to write, the REST interface that accesses a SQL database that we will be building in a moment, we are going to use strict null checks from the beginning. It's a great time to introduce a new compiler feature, implicit any. So if we remove this type annotation, the program will actually still compile, so let's run it here quickly to see that everything is working as expected. As we can see, it still works, the program, but we would like to prevent this situation. We would like to prevent that the compiler automatically assigns to a variable the default type of any if it cannot infer the type. We would prefer to receive a compiler error saying that the type of this variable is unknown. If we want to force that behavior, we simply go to the tsconfig.json and we change the value of the no implicit any variable from false to true. So this means that the compiler will no longer assign implicit any to certain variables or function return types. If we go back to our program, we might be surprised to find out that this statement is still compiling, and if we hit Ctrl+Shift+P on top of the player variable, we can see that the TypeScript compiler was not assigning any to this object. So the compiler was determining that the object followed this type, so it contained these three properties. So this was not an example of where an implicit any might occur. But if we create here a function, let's say that the function is named create message and it takes an argument of type message. Now we can see that we get here an error. Parameter message implicitly has an any type. So this is the case where the compiler typically will assign any types in input arguments of functions to which we did not add a type annotation. Before, the compiler was implicitly adding here any type, but now we are getting an error. And we can fix the error by explicitly defining the type of the method parameter. Now the error in the learning types file is fixed, but if we look here at the error panel, we can see that there are a couple of other errors, so let's fix them as well. This is in the build person data file. Let's see the error. One way of fixing the error would be to define a type that has a first name and a last name and apply it here, but nothing prevents us from also using the any type in this case. So we still have the option of using anywhere in the program where we would think that it's a good solution. So in this case, I'm just going to define address as any array, and now our program compiles again. So if you have an existing code base and you turn on this flag, no implicit any, you will have some refactoring involved. That is why the flag is false by default. But if you are writing a new program, I would advise you to turn on the flag and set it to true, and strict null checks also true. This way you will have the best experience while developing a program in TypeScript, taking advantage of all the type safety features that are there available, but that for the moment are temporarily off by default, mostly to ensure an easier migration from previous versions of the language. If by some reason the library that we are using does not have its type definitions available in NPM, we can always create our own type definitions. So let's say that, for example, Lodash did not have its type definitions available in NPM, and we were installing it using the require statement of CommonJS. Let's go to the command line and we are going to remove the type definitions of Lodash from node modules at types. So with this we removed from at types the definitions of Lodash. We only left the definitions of the Node.js runtime. So now our program is compiling correctly, which is something that we might find surprising, because let's have a look at what the type of this variable here is. This is of type any, but this is not an implicit any. If we hit Command or Control in Windows, we can hover over the require definition and we can click into it, and we jump straight into the definition where this value came from. So here we are inside at types, and this is the index of the types of the Node.js runtime. So you can see that the require import function is a function type of type node require. So if we hit Command and we click over it, we are going to jump into a definition that says that node require extends node require function. If we jump into this definition, we can see this function takes a string, so it takes a single parameter as a string. The parameter will be called id, and the return type is any. So that explains this any type here. This comes from the type definition of the require function. And we're going to understand, take a look, this is a file named .d.ts. So this is a type definition file. We're going to understand what's the difference compared to plain TypeScript files. Let's create a similar type definition file for the Lodash library. So this is just an example. Usually we would simply use the standard type definition file. Let's create here a file called myLodash, and we're going to give it the extension .d.ts. So this is a type definition file. In here we are going to declare a type called Lodash, and we are going to say that for the moment Lodash is equivalent to the type any. Now let's go back to our program. We can now directly use the new Lodash type that we just created. As you can see, the autocompletion already shows it here. If we simply hit enter, we have now said that this variable here is of type Lodash. So if we hit command and we hover over the Lodash type definition and we click on our mouse, we are going to jump to our type definition file. Now what we want to do is we want to manually define the different functions that are part of Lodash, such as for example first. Let's start by declaring Lodash as an interface instead of a type. So this will list a series of functions that will be basically the Lodash API. Now in order to declare the first function, we are going to declare another interface and we are going to call it first function. Now we are declaring here a function type as we have seen before. So we are going to start by the arguments of the function. So in this case we are going to define only one argument, which is an array of any, and the return type is of type any. So this is just an example of what the declaration of first could look like. Now we are going to use this function type that we have just defined to define a function named first. So first is of type first function. So if we now go back to our program and we remove the call to first here, if we hit Control space, we can see that first shows in the autocompletion list, and you can see the name of the parameter data, which is an array of any, and the return type is any. So with this we can autocomplete our program and we can pass it in the colors variable. So this is one way of adding types to an existing library that does not have them. We can declare them ourselves if needed. In the case of the Lodash library, we really want to use the types that are available via npm. So if you type npm install again, because the type dependencies had been saved here in dev dependencies, now our types are again installed under add types, and you can always confirm by opening the node modules project. So here we no longer need the Lodash type. The correct syntax to use for the remainder of the course will be import star as Lodash from Lodash. So if we click underscore here and hit Control space, we can see that all the type definitions are again available. Let's now learn how to debug TypeScript. So the first thing that we need to bear in mind is that TypeScript is not the code that is actually being run in the browser or in Node. We are running plain JavaScript. And in order to be able to debug TypeScript, we need to provide to the debugger source maps so that it can map between the JavaScript code and the TypeScript code. We can see here that in the tsconfig.json file, we have source map set to false. But if you expand some of these nodes, you might notice that you have here some ancient.js.map files, even though we have here source map set to false. These files were generated by the IDE before we had added here a configuration file to it. So if we now remove them and we make a change to the file to trigger its recompilation, we will see that only the JavaScript file is being generated and not the map file. So if we delete the ancient map files that we might have here, they would not be generated at this stage, so we would not be able to have our debugger show us the TypeScript code. For that, for enabling source maps, we simply change this flag to true. Now, whenever a program gets compiled, in this case it's being compiled by the IDE, but we could also compile it via the command line using tsc, we have the source maps that are available now, so we can start debugging our program. We will demonstrate first how to debug this hello-world.ts file in the browser, then we will move to the server. We are going to run this program in the server and we are going to debug it using both WebStorm and the Chrome DevTools as well. There is a way to debug Node.js programs in Chrome. So let's get started. First, let's start our HTTP server. So if we go back here to our package.json, we had here this small npm script that would allow us to run an HTTP server that loads the index.html page, which loads the Hello World program. So if we now switch over to the browser, we would be able to see this program working in the browser. We have here in the console, we can see that the program is working. Now if we hit the sources tab, we can see here that we have a samples folder and that we have here a TypeScript file and a JavaScript file, also for helloworld.js. This means that the source maps are working, that the debugger can do the mapping between TypeScript and JavaScript. So if we add here a breakpoint and we refresh the application, we can see that the breakpoint is hit, and take a look at the tab here, the name of the file. We are debugging the TypeScript file in the browser, which is exactly what we wanted. So we don't need to debug the transpiled JavaScript sources, because this becomes less readable as the program becomes more complex. Take a look even in this very simple example. From the moment that we use modules, it becomes rather complicated. So the TypeScript source is much more readable and it's exactly the program that we are writing. So I will release here the breakpoint and I will remove the breakpoint here from the browser. We are going to go back to the code and we are going to learn how to add a breakpoint programmatically. So for doing that, we simply add the debugger statement. So a single line ending in a semicolon, this will trigger a breakpoint in the browser. So let's switch over to the browser and reload the page. We can see that the debugger statement indeed triggers a programmatic breakpoint. Let's now go back to the IDE and learn how to debug the same program that we just debugged in the browser, so it's hello-world.ts, but this time we are going to debug it in Node.js as a backend Node process. So let's see how to do this. In order to do so, we can add breakpoints to the program directly to the TypeScript file by clicking with the mouse here. For example, let's add a breakpoint here to this line. Notice that you don't have a checkbox yet. This means that the breakpoint was not yet fully applied. So let's see how we can apply a breakpoint here. First, we are going to go to Edit Configurations and we are going to create a new Node.js configuration. So if you open the defaults here and select Node.js, we're going to click Add, so the plus button, and we have just created a new configuration and we choose Node.js, so we are going to debug a Node.js process. We are going to give it a name, so Hello World, and we are going to point it to the same node interpreter that we have been using. So in this case 6.9.0, and for this particular example we won't be needing any more parameters, so we click apply and then OK, and we will have here Hello World available. So we need to specify here which JavaScript file we need to debug. So in this case, we are going to debug the hello-world.js file. So it's important that you point to the hello-world.js file that was generated by WebStorm after saving hello-world.ts. If you point to the TypeScript file, this will not work. We need to point to the JavaScript file because that's what is going to be executed at runtime by Node, and that's what it's going to be debugged. Then the source maps are going to show us the TypeScript code. Let's try this out. We click apply, OK. So now we have here the breakpoint and we are going to run the program in debug mode by clicking here the debug button. So let's do that, and immediately the breakpoint is hit. So you can see this dark blue, this means that the breakpoint was hit. If I add here another breakpoint, notice that first the red dot was fully red, and now you have this small tick that says that the breakpoint is valid. If you hit here on resume program, you're going to see that the next breakpoint is hit, and we have here, for example, in this variables pane, we have here all the variables of the program, so we can debug our program in TypeScript in the IDE, and we don't have to debug the sources themselves that were generated as the output of the compilation. We can do our debugging directly in TypeScript. We can also debug Node.js processes using the Chrome DevTools, just like we did before in the beginning of this video for debugging hello-world in the browser. So for that, we can head over to the command line, and we are going to use certain flags that are available in Node since the release 6.3. So the first flag that we need is -inspect, and the second flag that we need is --debug broker. Then we need to pass in a JavaScript file. We are going to pass in hello-world.js, so it's important that we point to the JavaScript file. We hit enter, and we are going to get here a message in the console saying that if we copy paste this URL to Chrome, we will be able to debug the hello-world program in Chrome using the same DevTools that we were using before. So let's try that. We passed in this URL that we received from the console, and we can see that the program is stopped at the beginning of the execution. So we can put, for example, here a breakpoint, we hit resume, and we can see that the breakpoint is being hit. Now, at this moment in time, we cannot apply the source maps here automatically to map this to TypeScript. So this feature of the Chrome DevTools is not yet available. We cannot, at this point in time, debug TypeScript in Node.js processes using the Chrome DevTools, but it will be available shortly. So it's a good thing to bear in mind and to check back from time to time to see when the feature is available. Hello everyone, welcome, Vasco here. Now things are going to start to warm up. We have given an introduction to TypeScript as an improved JavaScript. We have learned a lot of the ES6 features that we're going to be using when building the REST API. Also, we have learned the most important feature of TypeScript, its superb type system that helps us to write programs in a very convenient way. Now, I know that the type system has a lot of features, but what I want you to focus in the next section is, first, how many of the language features are rarely used compared to certain features that are almost used everywhere in every function that we write. Also, I would like you to notice that although the TypeScript 2 type system is extremely powerful and has a ton of features, it mostly allows you to write programs without even thinking about it, without even noticing that it's there. If we choose the right combination of compiler flags from the beginning, namely if we set no implicit any to true to avoid implicit any, and we use strict null checks from the beginning, we're going to have type inference basically everywhere. We will only be forced to add type annotations to arguments of functions. From there, basically almost everything is inferred. So you will see that the type system, although it's very complex, it mostly gets out of the way and just helps us to build programs by pointing unexpected errors. This is going to happen all the time. We will be coding and TypeScript will pop up an error that is really not apparent just by looking at the program. We will also see TypeScript autocompletion and variable refactoring of the WebStorm IDE in action. We're going to see all the little tooling features that are made available by a type-safe language and how they help us to build a better program. So without further ado, let's get started with our REST API. The first step is to set up a development database, because that's one of the first tasks that we're going to do. We're going to query a SQL database using TypeScript. As you know, TypeScript has many more language features than the ones that we covered until now. But don't worry, we are going to cover those features later, and that includes object-oriented programming, generics, and decorators, among others. So we will cover those later. Right now we already have the basis to write a solid program, and that's what we're going to start doing in the next section. Hello everyone, how's it going? Vasco here from the Angular University. In this lesson we are going to start building our REST API in TypeScript. The first thing that we are going to do is we're going to create a simple query that queries the database. We're going to select the list of all courses. So for that, let's create here a folder called server, and inside it we're going to create a file server.ts. Let's create the first statement of our server. Just say server is running. You will notice that once you hit save on this file, you will have here the JavaScript and the source maps file associated to server.ts. So this was generated for us automatically by WebStorm, because we have here in preferences, we have selected under TypeScript, enable the TypeScript compiler and track changes. That's why these files are being generated on the fly without our intervention. This means that running the server at any moment in time, it's as simple as running a node server process that takes this server.js as an entry point. So if we go to the command line and we do node and we pass it in the server.js file, this is going to print to the console hello world. I would like to show you an alternative way of running this server configuration. We're going to use a utility called tsnode. Tsnode is a Node.js utility that allows us to run programs in TypeScript by passing in the TypeScript file to the tsnode executable. So this is useful in situations where, for example, you don't have an IDE that is compiling all these files on the fly. Let's have a look at it in action. The first thing that we are going to do is to install tsnode. So we type npm install tsnode and -D so that we install tsnode as a development dependency. After a while, the installation will be completed and you should see here tsnode in the development dependencies of your package.json. So now how can we use it to run server.ts directly? Let's create here a task and we are going to call it start. This is a standard name for a task that runs a server if your Node.js module is a server. So we are going to use tsnode and we are going to use the version that is locally installed under node modules bin, because there could be multiple tsnodes installed. You could have one installed globally. So this is the one specifically that was installed for your project. And here we are going to pass it in the server. So we are going to go to the server directory and we are going to pass in the server, not .js but .ts. So this is really, it's taking the TypeScript file, it's compiling it on the fly. So you are no longer relying on the IDE to compile this after each save. This will be done on the fly each time that you run start. Let's try this out. If we head over to the command line and we type npm start, we will get the same result in the console, server is running. So this is the method that we will be using in the future, in the remaining of this course, to run our server. We are going to use the utility tsnode. Using tsnode has the advantage that you don't need an IDE that it's constantly compiling the files. You could even follow this course by using a very simple text editor like Sublime, for example, and the tsnode utility will take care of generating the JavaScript files and the source maps for you. Now that we have a practical way of running our server, let's start by writing our first SQL query. It's coming right up in the next lesson. Let's now write our first SQL query. We are going to retrieve the list of courses from the courses table. So for that, let's show here first one thing. We are going to switch to the query tool and we are going to do a select to the courses table. Notice because courses starts with a capital C, you need to wrap courses in double quotes, otherwise this will not work. So if you hit execute, you will have here the data of the courses table. So you can see here that each course has an ID, and then it also has a URL, a description, etc. In order to query our Postgres database, we are going to use the Node.js Sequelize library. So this is a typical example of a library that was initially written in plain JavaScript that we would now like to use in TypeScript and still take advantage of type safety as much as possible. So we have here in the Sequelize page examples of how to use it in plain Node.js. What we're going to do is we're going to write all our queries in TypeScript and take advantage as much as possible of the type safety of our program. So in order to install Sequelize, the first thing that we need to do is we need to npm install it. So this is not a development dependency, this is really a runtime dependency. So we're going to install it with the -S flag. Now that Sequelize is installed, let's import it into our TypeScript program, or let's try to import it. At this stage, if we try to import Sequelize in our TypeScript program, we get an error. And let's take a look here in Node modules to try to understand what is going on. So if we head over to the Sequelize folder and we open it, we can see that there are no type definition files. Inside you will only find JavaScript files, plain JavaScript files. There aren't any TypeScript files containing, for example, type definitions that we could import in order to be able to import Sequelize directly in a TypeScript program. What we could do instead that would work is we would import this using the standard Node.js syntax. So this would work and we could still build all our program in TypeScript, still using libraries that are only available in plain JavaScript, so this would not be a problem. But we really want to take advantage of the features that TypeScript provides us to build a type-safe program. So what do we do in this case? For the most commonly used libraries like Sequelize, Express, etc., there are type definitions available in npm. So in this case, let's install the type definitions for Sequelize by installing @types Sequelize, and we are going to save this as a development dependency. So after the installation is completed, we can see that if we go over to @types, we will see that Sequelize is here available. And after a while, when the IDE indexed all the types that were downloaded, we no longer have an error. Notice that we should only resort to types available on @types if the modules that we are installing don't provide their own types. So if you are using something like typically Firebase, Angular Fire, and many other newer libraries that already provide their own type definitions bundled together in their npm package, then in that case you don't need to use @types. The types will be taken from the node module itself. Notice that there is even the error of if you take a module that already provides their own types and by some reason you go to @types and find there some similar type definitions and you install those, you might get into a duplicate type error where you have duplication of types, and this is something that we would like to avoid. Now let's go on with our program. Let's start writing our SQL query. Before going any further with our program, let's now give here some more structure to our server. So we have here the file server.ts, which is in the root of the server folder. But here on the server program, we are putting in here everything, model definitions, queries, etc. Let's split this up a little bit. Let's create here a couple of folders. Let's create, for example, a folder where we are going to put in all the model definitions of our database. So this is where we are going to store our course model. Let's create another folder where we are going to put the queries that we will execute in our database. Another name would be persistence, but let's simply call it queries. So let's start by putting the course model here in a file inside the models folder. So we are going to create here a file which contains a function that will initialize the model. So we will call the function init course model. And because that file will only contain a single function, I will give the name to the file, an identical name to the function itself. So we're going to export here a function which is called init course model, and this function is going to take the sequelize instance that we shouldn't create each time. We should reuse the same instance. We're going to copy this import over. We won't be needing logging options. We're going to pass in here the sequelize instance. And with the sequelize instance, what we're going to do here is we are going to return this model definition. So if we return the result of calling sequelize.define, this will be the model definition. So we need to import also ORM here from the sequelize model, otherwise the program will not compile correctly. Notice here the export keyword. Without this, the function will not be visible in the server file. So what we can do now is, instead of calling here sequelize, we can call the function that we just created that is already now available for autocompletion. So if you had not added the export keyword, it would not be visible here. So that is important to bear in mind. So if we hit save, we're going to see that we get here an error. And the error is that the supplied parameters are not the ones expected. So if we hit Control Space here, the first hit is the sequelize instance that we have here, and this would solve the problem. So we no longer have the course model definition here in the server file, it's in a separate file in a separate directory. So other models will also have their own corresponding file in this model directory. But we could take this one step further. So let's say that instead of exposing the init course model function, we're going to make it private to this file. Now we will get here an error saying init course model has no exported member. So what we can do is make this variable part of the module. So let's move this here inside this file, const course module. We are going to export it so we can also export constants. But take a look, the init course model needs the sequelize instance. So we really don't want to create it on each file. One way to solve this is to create here another file. We are going to call it model.ts, and inside we're going to paste in our ORM instance, and we're going to define here inline all models and export them as constants. So let's go back here, we re-export this function and we remove the course model from here and we add it here to the model.ts file. Now we need to copy in here some imports that we're going to take from this file. Actually, this import here will no longer be needed in server.ts, and this will go to model.ts. Also, the DB URL and the options we won't be needing here, so you will see that in the end we will have very little on the server.ts, which is actually a good thing because all the model definition, all the initialization of the ORM is in a separate place in the application structure. Everything will be under model. So we have here the database URL, the options, and now we need to import the init course model function. We do so with Alt-Enter. So here we have it. Now the course model is available, the program is compiling. So if we go back here to this server.ts file and we hit Alt-Enter, we will have a compiling server.ts file. So our program is compiling. We can confirm here on the TypeScript folder there are no errors. So as you can see, we have reduced significantly the content of server.ts. We are just calling the course model and calling find all on it. Let's quickly confirm that everything is still working as expected by going to the terminal and running the program using npm start. We should still get the list of courses, which is the case. So everything is still working as expected. So let's now define an express route, a small HTTP service that will return us the list of courses. Take a look, the return of express is of type application. I am here adding the type explicitly, although it could have also been type inferred. So we have imported application from express. Now what we can do is we will define a route using autocompletion. We are going to pass in here a path to the route. So we are going to use /API/courses. So this is the URL that the user is going to hit to retrieve the courses under the form of JSON. And here we are going to say that if the user does a HTTP GET, so it doesn't have to be a user, it can be another program that is doing an HTTP request. Here inside GET we need to pass in a function that takes as parameters the request and the response, and inside the body of the function we don't have to return any value, but we should take the response and we should define the HTTP status code of the response. So in this case it's going to be status 200, meaning 200 OK, meaning that the server finished processing the request correctly. And we are going to return some JSON to the client. So we will define here, for example, an object which has a parameter which is a message and the value is hello world. So to apply this change we need to stop the server and restart it, and we're going to see in a moment a way that we could hot reload this new change so that we don't have to stop and start the server manually. Right now let's try this change here. If we open a browser and we head over to port 8090 and we hit the URL /API/courses, we are going to get here message hello world. So our JSON object is being rendered in the body of the HTTP response. If we inspect here in the network tab the content of the response, let's just take a quick look at it. We will refresh the browser, we will inspect the response, and we can see here that the response body contains the message, and in the headers, in the response headers, we have here content type application/JSON. So this is what we are looking for. Now, instead of returning the hello world object, let's actually return the output of find all courses. So if we take this code and we paste it in the body of this route handler, we will simply uncomment the code and let's format it a little bit there. So we have here the call to find all courses. This returns a promise, and we were calling .then and printing the promise to the screen. Now, instead of printing the result to the screen, we are going to add here a success handler that will render the response with status 200, and instead of passing the hello world object, we are going to return as JSON the results of the query. So if we stop and start the server, and in the next lesson let's install immediately a way to hot reload this. If we have the server again back and running, we will refresh the browser, and here we can see that we have the response as JSON. And so we have implemented our first REST API call. There was a lot going on in this lesson, so let's quickly summarize. We have a very basic Express server up and running, and we have defined our first route. The route defines what should happen whenever an HTTP request hits the server at a given URL, in this case /API/courses. If we hit this URL with a GET HTTP request, we are going to trigger this response handler. The response handler will simply query the SQL database using the find all courses method that we have defined before, and it will return a promise. By calling .then on the results of the promise, we will get the data. We will send the data back to the client, which in this case is a browser, but it could be another program doing a REST API call. We will return the HTTP status code of 200, and we are going to return the database data under the form of JSON. Now, before going any further with the development of the server, we have been stopping and starting it manually by hitting Ctrl+C in the terminal. Let's install quickly a way of doing hot reloading while doing Node.js development that is going to serve you in many other projects. It's coming right up in the next lesson. Let's now improve the error handling behavior that we have while doing a database operation that fails. Now, the behavior that we get is the default error handling behavior of returning 500 internal server error and terminating the rendering of the response to avoid hanging HTTP requests, which is okay, but we would like to give a specific error that tells the REST client what happened exactly. So there was an error creating the lesson. So in this case, what we can do is we go back here to the API create lesson method, and what we're going to do here is we are going to add a more specific catch call. So we are going to do catch here of the error, and for the moment let's define an inline function. We can always refactor it later. What we're going to do here is we are going to log to the error console. What we're going to do here is we are going to log to the console this error to see what information we have here available. Now what I will do is I will add a breakpoint here, and let's quickly see how can we debug this REST API server using WebStorm. So I will go here to the terminal, and I have actually already stopped the server from running. So we will go here to the debug configurations, we select edit configurations, and we are going to take the configuration that we had created before, and we are going to do a copy of it using this icon here. We hit copy, we are going to rename it as debug REST API, and here what we're going to do is we leave the node interpreter 6.9.0 like we were using, we leave the working directory, and instead of samples hello world.js we are going to select the server file. So we go to the server directory and we select server.js. So again, it's important to select the JavaScript file and not the TypeScript file. We click apply, we click OK. So if we now hit the debug button, we will start the REST API server in debug mode. So now if we go back to the REST client and we hit play to trigger again the insertion of a lesson, we're going to get an error back again, and we would expect this breakpoint to be hit because we have here this check symbol. So it means that the breakpoint is correctly installed. Let's give it a try. So as you can see, the debugger is working, and we can see here what is the content of the err variable. So we have here a message value. We have a name, it's a SQLized database error. We actually have the SQL insert that was generated here. So we have here really a lot of information. Let's say, for example, that we have here an array of heroes, and you can see that these are objects. So each object has a property which is a name and a value that is a string. We could define such a type by using an interface. So we could declare an interface named hasName that has a property which is a string. So we can now use this interface to add here a type annotation and say heroes is an array of hasName, and the program would compile correctly. Now let's say that we would like to create a clone of this array. So let's call it here to the clone array clones, and we are going to declare it as being also as a type of array of hasName. In order to clone the array, let's define a function cloneArray. So in order to clone an array, we are going to receive an array as input. And notice that now we receive an array implicitly has an any type. We are going to declare this as being an array of type any, because the array that we want to clone could be of any type. And the return result of this function should also be an array of any. Let's do a very simple implementation of this method. We are going to use the slice array operator. So we are going to slice the array starting at position 0. So this will effectively create another array similar to the heroes array. Now we can use this function, but take a look, we are using the type any, so this is not type safe code. We can use cloneArray to clone it. So let's try it out. We call cloneArray and we pass in heroes. Let's now log out the result to the screen. As you can see, we have no further compilation errors. Let's try this out in the terminal. So as usual, to run this file generics.ts, we have created here in our package.json a generics npm script that we can run with the command npm run generics. Let's do that in the terminal. So if we do npm run generics, we are going to get the cloned array printed to the screen as expected. So this is working. So what is the problem in this code that generics could help us improve? Take a look. This variable here, clones, if we do Ctrl+Shift+P on it, we can see that it's of type hasName array. But this is only because we have defined the type explicitly. Because if we remove the type annotation, we will see what is the type that is being inferred. So it's an array of any. So with this definition of clone array, we have not preserved the type of the array that we were cloning. We took any array and we returned an any array. So we can no longer rely here at the level of the clones variable in type inference to help us write our code. We would like to improve upon that, and there is a way to do it using generics. Let's turn the clone array function into a generic function. For that, we use this angle bracket notation, and we define here a type that will be used inside the function. So this type could be any character. We usually by convention use the T majuscule. Now this is a type definition and we can use it here inside the functions. So instead of any, we are going to use here the T type, and we will also return the T type. So if we hit Ctrl S, we can see that everything is still compiling correctly, but now this program is type safe, meaning if we go to clones and we do Ctrl+Shift+P, we can see that this is now a variable of type hasName. Notice that we did not have to add here, for example, the type hasName, although we could have, but this was not necessary. With TypeScript generics, we can infer the T type based on the input parameter of the generic method. We don't have to define the generic type explicitly associated to the function, although we could. Notice also that T does not have to be an interface or a class or a custom type in general. We could also have here, for example, an array of numbers, and we could create an array called cloned numbers that would clone the numbers array. So T can also be implicitly a primitive type. Again, we could have defined here the type number explicitly, but we didn't have to. Type inference determined for us that cloned number is a number array. So as you can see, the generics functionality is very useful for writing code that is independent of the type. This is typically the case in methods that handle containers of another type. We want to be able to work with the container, in this case the array. We want to be able to use slice, filter, map, reduce, and all the standard array operators without independently of the type contained inside the array. We want to be able to preserve type inference across our program without having to write multiple clone array functions for different types other than hasName. We want to make the function generic, hence the name generics. Let's now understand how can we use target, property key, and the descriptor to implement a decorator such as the log method decorator. Notice the following: descriptor.value is pointing to the save data function. So one thing that we can do at this moment is to replace the descriptor value with a new function that adds some extra functionality to the save data method, sort of by wrapping the original function. What happens is that descriptor value is overridable. So let's say that we want to replace it with a new function. So this would effectively replace save data with a completely new function. Let's try this out. Let's define here a function inline using the arrow operator, and we are going to log to the console here a message that identifies this as being the new function being called. So if we go back to the terminal and we try this out, we can see here that new function is being called, and we also have here a logging statement of the descriptor that we are going to remove. So the new function here that we have overwritten in the descriptor.value is being called instead of the original function save data. So the method decorator is a mechanism of overriding functions to which we apply the decorator to with some new functions. This type of functionality that we are about to add is sometimes known in other languages as aspect-oriented programming. Now, most of the time, we don't want to completely replace the new function with a new function. We want to enhance the existing behavior of the function that was decorated. So in this case, what we usually want is to enhance the original function. Let's create a variable that points to the original function. So descriptor.value contains at this point in the program the original function. Now it has been overwritten at this point in the program, but here we still have a reference to the original function. This means that we could call it here. So let's try this out. If we run our program, we are going to see that the new function is called here and the original function was called. So we have here saving data in the database, but we have here undefined. So this first attempt of replacing the original function with a new function that adds extra functionality is not completely working, because here we are calling the original functionality with no arguments. What we want to do is we want to pass in the arguments that are called to save data, so in this case the data, and we want to pass it to the call to the original function save data. So we want to add here some logging and we want to still call the function with the exact same arguments. In order to implement that, we are going to use here the REST operator to create an args parameter for this function that will contain essentially all the arguments that are passed in each function call. So this will be an array with only one element, and the element will be the value of the data that was passed in while calling save data. We can now pass these arguments to the call to the original function. Let's add here a type annotation. We know that at this point original function is of type function. So if we go here and we use autocomplete, we can see here all the operators that are available to be applied in a function. We're going to use apply, and for the moment we don't know the content of this, so the first argument of apply is the value of this in the function that is being called, and the second argument is an array of arguments that we want to pass into the function. So in this case we are going to pass in the args argument. Let's try this out in the terminal. We can see here that new function, so this logging statement is being called. The original function save data is still being called, and we still have here undefined. So we are passing the arguments here to save data, but we are actually not using them. So let's fix this. We are going to add here some more information. We are going to concatenate it here to this string, to this logging statement, and also we are going to select here this concatenation expression and we're going to replace it with a template string to make it more readable. If we now execute again our program, we are going to see that now we get something here. So we still get undefined when we call this.data, but we are now getting here some data. Let's do a JSON.stringify of the data to see if we are still getting the original data that we called, so the message hello world. If we now run our program, we can see that message hello world is still being received. So this log method decorator is taking the original save data and it's enhancing it. We are still passing to it all the arguments, so we are still passing to it the data that it's trying to save in the database. So this part here is working. By the way, in the aspect-oriented programming terminology, what we have implemented here is known as a before aspect. We still have a problem, which is the content of this in save data is undefined. So what's going on here? Let's fix that, because that's the last piece of the puzzle to have a function decorator in place. In this section, we will go back to our program that we have been developing so far. We are going to enhance its type safety by defining a couple of custom types, and we are going to apply those types to our program, and we are going to see how it helps us build better, more readable programs. We are going to see how to install typings for commonly used libraries such as promises, standard promises or bluebird promises. Specifically, we are going to see how generics really helps us to write promise-based code. We're going to learn how to write mapping functions that map database tables into types that are returned by our REST API. The types that we are going to define will be reused later in the front end of our application when we build our small Angular 2 application. The biggest takeaway from this section will be we will see how to build complex types in TypeScript, custom types, and we're going to see how that benefits our program. We are going to take concepts like course, lesson, and we are going to embed it in our program, not only under the form of variables or function names. We are going to create types for those concepts and we're going to use them to build our program. You will notice that the types that we are about to define do not use object-oriented classes. So without further ado, let's get started defining some custom types. We're going to start doing that in the next lesson. You might have noticed in the part of the course where we were building the first version of our REST API that not all the fields that we were receiving in the front end were exactly what we wanted. Let's say that, for example, we have here this created at and updated at fields. We would not necessarily want to send this to the front end. What we are sending here is the whole content of the database table, but in many cases we would like to send a part of it to the front end. Also, for example, here we are sending a capital lessons array of lessons. This is another example where we would like to name this lessons with a minuscule L as well. So not always the names that we use on the databases will be the ones that we will be sending to the front end. Actually, in a typical case, the names of the columns in a database are actually very different than the ones that we use in our programs. There is another aspect to it, which is we have not defined a type in our program for these concepts of courses, lessons, and the lesson has many courses. If we would do so at this stage of the course, we would significantly improve the type safety of our program. Also, those concepts, course, lessons, they are necessary in both the backend, the REST API, and the front end. So we will be building a small front end that queries the REST API and displays the data on the screen. So the front end code would also need these notions of course and lessons. So let's add these notions to our program under the form of custom types. Let's start by creating a folder called shared that will contain all the code that is shared between the backend and the front end. And inside it we're going to create a folder named model. Now we are going to create the first type of our program, which will be course. We are simply going to call the file course.ts. Inside course.ts, we could define here a type named course, and this would contain the definition of all the fields in a course. So for example, one of the fields would be the description, which is of type string. A second field will be the URL, also a string. And so forth. There would be other fields, so I'm going to paste in now here a series of field definitions, so long description, icon URL, etc. Now, we should use type for defining type aliases and not object types themselves. To define object types themselves, we are recommended to use the interface keyword. So we have defined here an interface for a custom type named course. So remember, an object can implement an interface. Another thing that we want to do is we want to expose this type, this custom type, for usage in the remaining of the program. Because right now as it is, we would only be able to use it here inside the course.ts file. So we are going to export this interface so that it can be imported in other files. When defining an interface like this, it's important to see which fields should be read-only. So if you have reasons to believe that a field should not be modified, we should mark it as read-only. And if certain properties are optional, it's important to mark them as such using the question mark. If you want to write your programs by relying as least as possible in the notion of mutability, you can systematically declare your properties as read-only, like we have done here. Notice that this does not mean that instances of course are immutable at runtime. At runtime, some arbitrary code could always mutate the object. At runtime, an instance of course will be just a plain old JavaScript object that can be freely mutated without any problem. Declaring our properties as read-only simply prevents that from happening in our code, because we will get a compilation error in our code if we try to change a property that is marked as read-only. So declaring a property as read-only, it's a compile time check only. It's not a runtime protection against mutation. At this point, you might have noticed that there is a property missing here in course. It's the lessons array that is available here in the response from the server. So in order to add the lessons array property here, let's first define the type lesson. We will do so in a file lesson.ts, and I'm going to paste in here the definition of the lesson type. So as you can see, we have again used an interface, we are exporting it, and we are providing here a series of properties. We will, for example, mark the tags property as optional. And if we go back here to the course, we can add here a property lessons, which will be an array of the lesson type. So with Alt-Enter, we can import the lesson type into this file. Now notice one thing, if we declare this array as read-only here, this only means that the reference to the array is immutable. But an array is a mutable type, so if somebody would call course.lessons.push, they would still be able to modify this property. So with this example of the lessons array, it's clear that adding read-only to all the properties of an interface does not declare the type as immutable. So it's an incomplete solution for immutability. So if you want to build your programs around that notion, I would suggest to use a third-party library like Immutable.js. I will suggest you to instead use the read-only property to protect against modifications in properties that are a natural key for the type at question. So for example, the course has a given URL. The URL should not be changed once the object is created, because that would mean that the object corresponds to a different course. So we could run to some really hard to troubleshoot bugs if we start modifying the URL of a course in a certain part of the code. So this helps with the readability of the program because it clearly identifies the natural keys of the course. So in this case, we have marked the URL as read-only, and let's take a look. The other properties are as mandatory because they don't have the question mark, and these flags are marked as optional. So what we can do is we go to the lesson type and we declare also its URL as being read-only. So you might have noticed at this stage a couple of things. First, that you have a course that has a list of lessons, but you might not always want to query a course and have all its lessons attached to it. Maybe you only want to display a list of courses, and for that you only need the description. You would not need the list of lessons all the time. And here it's marked as a mandatory property. We could mark it as optional, but we are going to see a better solution